Okay, we are back. This is Techmath1. We are in the red book. We're doing chapter 5. This is 5.5. So let's take a look at number 42. They gave us this problem, and so we want to use the quadratic formula. That is right here. And so this is a way to solve without factoring, without completing the square, all those other things. And so A is always the thing in front of the x squared. It's always ax squared plus bx plus c equals 0. That's standard form. So 1 is in front of there, so we'll put a 1. 6 right there, and negative 16 is right there. Be careful to maintain the signs. If there's a minus on it, it's a negative number. All right? So now we substitute. Here, I'll put them in blue so it looks a little different. C all over 2a. So that is the quadratic formula. This will work every time for a second degree, any second degree equation. So if this were gone, if it was just x squared minus 16, we would say a is 1, b is 0, c is negative 16. So it doesn't matter if you have all three, just as long as there's an x squared, you can use this. So now, let's see, the opposite of b for a, c, all over 2a. So I put in a, b, and c, and now it's just plug them in and chug out the answer, plug and chug. So negative 6 plus or minus the square root 36 plus, what is that, 64, I think, right? 4 times 16, yep, positive 64, all over 2. So what is that, 10, carry the 1, 7, so that's 100. So x is equal to negative 6 plus or minus the square root of 100, all over 2. And now I can do the square root of 100, so x is equal to negative 6 plus or minus 10, all over 2. And now I can split it into two answers. So x is equal to negative 6 plus 10 over 2, and x is equal to negative 6 minus 10 over 2. All right, so that's 4 over 2, which is 2. So that's one answer. And that is negative 16 over 2, which is negative 8, which is the other answer. So when it works out to be a perfect square under there, that means this was factorable. So if you would have attacked this problem differently without doing quadratic formula, it would have been, you would have factored it into, multiplies to be negative 16, adds up to be positive 6. That would be plus 8 and minus 2. That's negative 16, but added is positive 6. And then now look, we say x plus 8 equals 0, and x minus 2 equals 0. And negative 8, x equals negative 8, or x equals positive 2. And so I've had students say, oh, this is way easier than all of that work. And I've had other students say, no, this is easier because I don't have to think multiplies to be that and adds to be that. I just plug them into this equation and it works every time. So whichever way you want to do it. Normally, if it is factorable, we do factoring because it's a little more efficient. But if it is not factorable, we can do this. Or if they're really big numbers or there's a leading coefficient, you don't want to do the AC method. So quadratic formula will work every time. And we will take a look at that at the end of 5 again. So we will revisit that. All right, let's look at the next one. Quad form, lovely, 5, 6. Let's do number 54. That's just writing it in standard form. So we're just going to do one of these. 36 is equal to y times y minus 4. So you do the distributive property, y squared minus 4y, and that equals 36. And so we want to move the 36 over to that side. So we have 0 is equal to y squared minus 4y minus 36. And then we'll write it forwards instead of backwards. We'll put this on the left side, and the 0 on the right side. And there we are. Standard form. So all you're doing with standard form is simplifying and getting everything over to the left. Usually with standard form, you want the leading coefficient to be a positive number. We never want that to be a negative. All right. Let's look at 5-7, applied problems. So I just want to do one applied problem there. Let's take a look. 5.7. We will take a look at number 63. They already have this pretty picture for us. It's a rectangle. X plus 1 and x. All right, and so area. The length of a rectangle is 2 meters more than the width. Oh wait, so this is a different problem. 2 meters more than the width. And the area is 11.25. Okay, so x times x plus 2, length times width, is equal to the area. Here, I'll write length times width equals area, and so that's 11.25. All right, so then when we do that, we can find the answers. Let's do it. We get x squared plus 2x equals 11.25. We move the 11.25 over. And we have a whole bag of tricks to solve this equation, the second degree equation. Factoring is kind of off the table because it's fractions or decimals. That's kind of a pain. We could have completed the square if we wanted to. That's kind of a pain. Adding 1. Yeah, let's not do that. Let's do quadratic formula. So a is equal to 1, b is equal to 2, c is equal to negative 11.25. And then the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So negative 2 plus or minus 4 plus, what is that? I think 45? All over 2. Oh, so this one does work out nice. Negative 2 plus or minus the square root of 49 over 2. That is negative 2 plus or minus 7 over 2, right? The square root of 49 is 7. So we get x is equal to negative 2 plus 7 over 2. And we get x is equal to negative 2 minus 7 over 2. So this is 5 halves. That's one of your solutions, or 2.5, or 2.5 if you'd like. They gave us decimals, so we'll give them decimals back. So 2.5. And then the other one doesn't make sense in the context of the problem. It's negative 9 over 2. But I can't have negative 4.5 be one of my sides. So that one's garbage because of the negative. So we tossed the negative answer away. And so they want the dimensions. So we got one dimension is 2.5, and then x plus 2 is the other dimension. So 2.5 plus 2. Positive 4.5 is the other dimension. And what is that in feet? Meters? Meters must be in England. Meters. Okay. Lovely. That's the applied problem I wanted to work out. Let's take a look at solving with graphing, 5.8. We're just going to graph a couple of problems. Now, they already have it graphed in the book. So if you want to follow along with that, you can actually look at it. But I'm going to show you how to key it into your calculator and find it. The one that we're doing works out nicely. But if it doesn't work out nicely, you can always use your calculator to graph and find the zeros. That's what you're doing, is finding the zeros when you solve. So let's look at 72. There's actually two problems. We're going to graph x squared plus 3x minus 4. And they already have it graphed for us. It's just lovely here. 1, 2, 3, 4. Okay, so they already have it graphed for us. So it says the two solutions for that problem are what and what, and that would be, well, -4 and +1. But let me show you how to do that on your calculator. What does that look like in the calculator? So in your graphing calculator, what that looks like is, turn it on, hit y equals, let's clear that out. All right, so y equals, and now we want x squared, so there's the variable right there, x, and then there's the squared. So it says x squared plus 3x minus, make sure you use the minus, not the negative button, -4. All right, and then just hit graph. And there's the same graph that they have in the book, except now we want the calculator to find it for us. So now look, second, and then trace, is calculate. And it says a value, a 0, which one do we want? So we want a 0. So hit down 1 to 0 and hit enter. Now, it says, okay, there could be a bunch of zeros on this. So you have to tell it where to look. So left click until the little flashy guy is above the 0 on the left, on the -4, 0, all right? And then hit enter. And now it says, hey, what's the right bound? So now right click, there's a right click button till the flashy guy is below the line. Because now look, we're trying to capture that point with these two boundaries. So see the little floating arrows on the top here? That's where it's gonna look for zeros. And now it says, take a guess. If you want to, you can click it on to where it is. Or you can just hit enter. I usually just hit enter again. And then voila. It tells me, here, let it focus in. It tells you the 0 is at -4. And now look at what it says for y. That's kind of weird, right? It's -1e to the -12. That's 0. That's basically 0. It's 0.000000 like 12 times, and then a 1. And so that's 0. Just if you get a weird thing like that, a -e or any e to a negative high number is basically 0. All right, so there was one of our zeros. Let's find the other 0. So second, trace, go down to 0, hit enter. And now it says, hey, I want a left bound, but now we already found that one. So now we want to focus on this one. So we're gonna move it to underneath the 0, and now hit enter. And now look, it throws an arrow up there. It says, okay, now what about the right bound? So now you're gonna right click till the flashy guy is above the 0. See how it's above the 0? All right, and then hit enter. And then it says, take a guess. This time I'm just gonna hit enter again and not guess. And it just finds it for you. And so now look, it says, what does it say? X equals 1, Y equals 0. And so there was our -4 and 1. And now, I wouldn't use it for one that crosses it exactly like that, and like the next one, but I would use it if it was going to be a decimal approximation. So you can put in these equations and graph them instead of using like quadratic formula. You could use your graphing calculator to find zeros. So there's another method of finding answers for these quadratic formulas. And so this one, it's at -1 and +2. All right. So graphing is another technique that can be used to find the answers for quadratic equations. So we've learned how to factor and solve. We've learned how to factor by completing the square. We learned how to use quadratic formula. We learned how to graph and find the answers. So there are multiple ways of finding answers. Truth be told, in the real world, graphing is used a lot with engineering and break even points and things like that. And usually things don't work out nice enough to be factored and solved. So the last one, 5/9, is really weird. So I want to show you number 78. They have RF squared minus HF plus D equals 0. And they want you to use quadratic formula. So remember what that is. The opposite of B plus or minus the square root, B squared minus 4AC, all over 2A. And now look at A is R. B is negative H. And C is D. So we're going to put these in, but we're not going to be able to calculate. It's just going to be a bunch of letters in our answer. All right? So let me put those in here. Let me go. I guess it's not X in this case. It's F. So F is equal to, and I'm going to do the opposite of plus or minus the square root of squared minus 4AC all over 2A. But now, instead of populating this with numbers like how we're used to, I'm going to populate it with letters. Ooh. So look, B is negative H. A is R. And C is D. And here we go. The opposite of negative H is just H, plus or minus square root. Negative H times negative H is H squared. Minus 4RD all over 2R. That's my answer. So it's not tedious. It isn't like, oh, we had to work it down and then there's a perfect square and then we had to split it up and then divide. But it is very abstract, and that can be a little mind-bending. All right? So that is it for Chapter 5.